Hello, Algebra 2 students. We're taking a look at solving and graphing two variable inequalities worksheets. And I'm going to be using Desmos here to show you. If you can get on Desmos, click this little pad down here, bring this up, and you have, your less than, greater than, your less than or equal to, and your greater than or equal to. And you can put these on here, and then you could actually see what you're graphing, what you're looking at here, and see if these answers are correct or not. I also have it on paper, and I'm going to show it to you on paper, what it would mean on paper. So you're checking whether 0, 0 is a solution. 0, 0 is right here. 0, 0 would be right here. Okay, so when we're looking at x is greater than -4, x greater than -4 is all the pink when you just put it in Desmos. And so 0, 0, yes, it is in there. Yes, it is in there. I have it here also. Here's my number one. This is -4 back here, and x is greater than it, so it's everything shaded this way. So yes, 0, 0 is in it, so you could even see it on my paper. Number 3. You have to rearrange to get y on one side. And I get y on one side by subtracting an x from both sides. So this one is looking like this blue one here. Notice that they didn't put y on one side. They just go ahead and graph it for you real quick. But notice that the y-intercept is -3. And then it's just down 1 over 1, down 1 over 1, down 1 over 1 is your slope, because it's a -x slope it ends up being. And so everything less than that is y. So 0, 0 is not in the blue section. You could also see it on my paper here for number 3. Here's my -3 y-intercept, and then my slope is down 1 over 1, down 1 over 1. So I just continued that, and everything below that is in the solution. 0, 0 would not be, so your answer is no. And here's number 5. I have to get y by itself by subtracting 2x from both sides. I have a y-intercept of 1, and then my slope is -2, so it goes down 2 over 1. Here's number 5 right here. The thing is, y is going to be greater than it. So y being greater than it, everything's shaded this way. So it would be everything shaded up here. Here's 0, 0. It just misses it. So that's going to be a no also. And you could see that on Desmos. Is each ordered pair a solution of the inequality? I did these on paper also. So for number 7, x is greater than 4, so I got a dotted line right on 4, and x is greater than it, so you're going to shade everything to the right of this one. And here's your 3, 2, and your -1, 4. These 2 points are not in the shaded region, therefore no, they are not a ordered pair. They're not a solution of the inequality. Number 9, I have this where I have to change to slope-intercept form. So I am just adding an x to both sides. So I get y is greater than x plus 5. So I start at plus 5, and then I go up 1 over 1, up 1 over 1, because I have a positive x. There's a positive 1 there. Even though you don't see anything with that x, there is a 1 there. So positive x, or positive slope, just means go up 1 over 1, up 1 over 1, up 1 over 1, okay? So, and y is going to be everything greater than it, so everything above this line. And your 2 points are 3, -2, and 4, 1. So these 2 points, no, they do not satisfy that inequality. Just grab a few points, 3 points. I just, grabbed 3 points in the shaded area, named them. I did that for number 11. I did that for number 12 also, 3 points in the shaded area. That's all you're doing for number 11 and 12. 13, if an inequality has a symbol of this or that, less than or greater than, then the graphed line will be, and I have 3 choices here. It will be broken, it will be dotted, it will be dashed. however you want to describe it. And then the other one, I went ahead and did 14 too. It's going to be solid if it has a greater than or equal to or less than or equal to. That little line underneath means, make it solid because it includes everything on the line. Okay, so number 15, y is less than 1, so I just go to 1, and it's dotted line, and everything below that line gets shaded. Okay, you could probably do better shading than I do. This one, I had to subtract 5 from both sides to get, I'm getting my variable alone, so I get x is greater than or equal to 3. So x is greater than or equal to 3 ends up being right here. Here's my 3. I make my solid line, and everything greater than that is over on this side. For number 19, I have y is greater than negative 3x. So it goes through the origin because I do not have a y-intercept. So my slope is negative 3, so that means it goes down 3 over 1. So down 3 over 1, down 3 over 1, down 3 over 1. I go back 1 and up 3, back 1 and up 3, because that's down 3 over 1, down 3 over 1. Okay, and then y is greater than it. So my y greater than, all my y greater thans are here. So it's this side of the line. I shade everything over there. And then last, number 21, I get y by itself by adding a 6x to both sides. And then I had to flip the sign because I had to divide everything by a negative 3. Dividing by a negative flips my sign, so I have y is less than or equal to negative 2x minus 6. I go to my negative 6 as my y-intercept, and this is my slope. I go down 2 over 1, so down 2 over 1. Y is less than it, so my y is less than or over here on this side of the line. So everything, so this line would keep going, everything over here is going to be, the solution. And including whatever is on this line, I can, keep it going a little bit straighter for you. So try the even ones on your own. Go ahead and make mistakes. We learn from doing so.